Assalamualaikum. My name is Shasha Nur Maisara binti Muhammad Hamzah. My metric number is AD180049. So I am from group 1. So our group is studying about static structural analysis of wheelchair. Next, the introduction of our wheelchair is wheelchair is a mobility orthosis providing appropriate support to allow maximum functional mobility. It is a combination of a postural support system and a mobility base that are joined to create a dynamic seated environment. So next, the components of the wheelchair consist wheelchair frame, stationary or foldable, seat and cushion, armrest, fixed or adjustable, stationary or removable, leg raise, adjustable or removable, footrest and restraints. So our group will do the analysis about the wheelchair frame. So in the real world problem, the selection of a wheelchair that provides the user with the highest possible level of performance to be considered a realistic expectation for both the future user and the wheelchair itself. When it comes to the first wheelchair prescription for a potential user, the research suggests that the effectiveness of wheelchairs is less than ideal and fairly varied. This is especially true in the situation where when the wheelchair is being prescribed for the first time by a significant measure. The wheelchair that is most often recommended to patients all across the globe today is the generic wheelchair. It is not difficult to form the hypothesis that this particular design was inspired by the need to keep things as simple and effective as possible. Next, it is the improvement in wheelchair technology that has enabled disabled people to have their requirements customized to suit their preference. We gave an example of the versatility of wheelchairs. Wheelchairs that are not very heavy have been scrutinized for this project. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Yana Shahira and I'll be presenting chapter 3, which is the method of assessment. So firstly, for the properties of material, since our objective is to find the most suitable material for the wheelchair frame, there are two materials under consideration, which are aluminium alloy and titanium alloy. So for the properties, we took directly from engineering data sources on ANSYS. Next, for the geometry development of the wheelchair frame, we developed the geometry in Design Modeler, where we mainly use the extrude features and using multiple axes. For the dimension, we took it from a standard dimension of manual wheelchair from literature. So for next, for mesh generation, as we know, meshing is crucial step in carrying out an effective simulation using finite element analysis. So as the geometry of the wheelchair frame has been developed directly using Design Modeler and not using other CAD software, the mesh is generated using mechanical without having to import the geometry beforehand. Due to the limitation of students version and NC student version, we have to set the element size to 10 mm each, and the total of nodes are about 100,000, and the total elements are about 50,000. Next, for the boundary conditions. The boundary conditions are also taken from the literature. Although static analysis can include constant initial loads such as gravity or rotational velocity and accelerations, the wheel is set as a fixed support as this project mainly focuses on the wheelchair frame. Besides the fixed support on the wheelchair frame, there are four other boundary conditions, which are the force exerted on the push handle, the armrest, the footplate, and as well as the seat frame. So after the boundary conditions have been set, after pre-processing steps have been completed, the model is ready to begin the solution phase. The solutions are defined in mechanical according to the results of interest, which in this case are total deformation and equivalent stress. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Atira binti Abu Talib, AD180130. For today, I will present about result and discussion that we obtained. The first result that we obtained is total deformation. So in the figure below, for the left side is titanium alloy and for the right side is aluminium alloy. So The deformation is responsible to the load or the force we apply to the wheelchair, and it change or deform the original shape of body in X, Y, and Z direction. The deformation always occur in push handle and pedal of frame wheelchair, as we can see the icicles in figure. So the value of the deformation for both material is 1.27 megapascal and 2.2017 megapascal, which is the aluminium alloy have the highest value of total deformation, greater than the titanium alloy. For the next result we obtain is stress equivalent 1 meters. The stress equivalent is used to predict the yielding of material under loading or under the pressure we apply. Maximum equivalence stress state in the figure, which is the value is 28.921 megapascal and 28.82 megapascal. The higher value of von Mises stress is 28.921 megapascal, which is the value of for the titanium alloy. Better than the aluminium alloy, which is the value is only 28.82 megapascal. For the next chapter is conclusion. As the conclusion, we can say the best decision is to choose the wheelchair material. It's based on the overall result, which is we discover the aluminium alloy material is better than the titanium because it is suitable to be utilized as the wheelchair frame material. That's all from me. Thank you.